Hello, let me continue from where I had left off in the earlier session. I had started with trying to show you how a few fasteners are used and what you do with various things. Now kindly look at this monitor and a few of the pictures I managed to get from the what do you call just by giving a simple search on Google this morning. Just this morning means maybe a few hours back. If you notice it, anything you want to make is probably made already out there. So, without adding my what I call judgmental remarks, just take a look at what all we have here. Obviously, we have two classes of items. One of them is typically these are all made for a well known what do you call technical thing called the Arduino. What else? Arduino and Uno. So, you will notice it that at one extreme, if you are one of those hackers who seems to enjoy making things yourself, obviously data is available. You can make use of it as much as you can. More and more pages, more and more hits, and then I will try to I have picked individual parts so that you can see what is going on here. You see here, it is sort of non-stop. See, at one extreme, we just need to make an enclosure, and being in the learning phase and I being in the teaching profession, we would like to see what is inside. And so, no better way to start than with the so called what you call universal thing. Right now, you can see here, I fully acknowledge both the manufacturer of this case and also the manufacturer of this what do you call module, which is typically the Arduino Uno and so many other things. First thing what you will notice is there are two very critical things you will notice here. First thing have you noticed, whole thing is held together by screws on the outside. So, you have a fastener here, can you see it? Then you can also see inside that there are fasteners. So, we have a fastener here, then we have a fastener here. Okay. And this what do you call module is held together by internal fasteners. Now, obviously, whenever we are looking at these technical projects, we would like to see inside, we use material like this, which is a way of a transparent polycarbonate or acrylic sheet. You see here it says polycarbonate and so on, while I do not justify any of these. So, depending on the type of material you have and all that, it is very easy to cut these things, polyplast. Now, you have, do you see this? This is a small clamp or something which can keep some other device inside like this. It was just made as a demonstration piece. Maybe I can keep my mobile here, it is falling off. I will not risk my mobile. So, see here, it is just a support like this. So, you see the one good thing about this what I call this type of polycarbonate is it is extremely strong and resilient. As such, it is a tough material. So, I will now take it out of the thing. I will show you now a case that has been made instead with acrylic materials. So, the advantage of this being that it is flat and completely insulated. See here, if I open it and then you will see the boards inside. Can you see? That is the famous old Arduino case which we have here. and the whole thing is held by this small. Yeah, I think for intentionally they have assembled it and kept it like that. So, these materials, these covers come in the flat condition. So, we have this flat condition, you see how it looks like, and the interesting thing what you need to observe is that we have these fasteners here. Can you see this here? I have a fastener, then I have a spacer, I have to have this. Now, when I turn it over, it looks a little ugly, but it is okay with me, not a big deal. More important is, in case or in the unlikely case, we have some optical devices. For example, if you have a ambient sensor or if you have a camera and all that, we have an option of replacing this top cover directly with a completely opaque material, or we turn it over and add a black what do you call cover for that. The moment you make it, now all the functionality what I wanted has been achieved. But what you need to first observe is that if you see here, that whole thing is a enclosure like this. You see here, I have this same case, this is transparent. If you remember, this is also a little like this Arduino, you know that I am not sure which is that board, and then we have these fasteners. This has been made using 3D printing. So, if you see the title of this what I call of this particular series was rapid prototyping with a little emphasis on 3D printing, and in our case we have access to laser cutting also. So, you notice here, if you see this piece, all the vertical pieces, everything has been printed using traditional printing. So, 2 or 3 features what you will notice is, first of all, everything is built in this direction up. So, if I go here, everything is neatly built up like this in this direction, see here. So, to the extent that there is no chance of any what you call something getting in the way, except that you see here I have a small dimple here, another small dimple here, obviously 2 things are there, and in the top cover again these dimples are also made. So, a small bit of what you call depending on the amount of overhang the particular system helps, it is possible for you to build a little bit of these details. And then later on, if you see here, you see this supports for the printed circuit board. This is a small what you call a flat piece, and then after that there is a projection. So, you can push the printed circuit board into this. So, we have one here, and there are absolute clearances for the hardware. Now, you see the interesting thing, when we come to this top cover, because we need to have a snap fit. Why I have chosen this particular object is that snap fit is also possible. Very first thing is, you need to build a rim like thing here, so that this rim goes and sits inside, and afterwards we have 1, 2, 3, 4 small devices here. So, obviously, you sort of hinge it, push it inside, hinge it and carefully push it in, and after that no fasteners, you understand, no, absolutely no fasteners. And I do not know why these slots are given, probably in the due course you will understand. Probably it is possible for us to manipulate a few things, or maybe connections. You need to provide a connector from the top which will come inside like this from the outside. After putting everything inside, you can push the connector inside. Now, you see how elegantly the whole thing has been made, and you see here we have the dual function device here. One of them, it makes a little bit stiffness, and this part gives us stiffness, this part gives us stiffness. The small thing is, this is possible that it may not get the stiffness we are looking for. So, in those cases, depending on the amount of material is available, it is very much possible for us to make a small projection here. If you make a same thing, a little small projection here, or a small and another here, or one little bigger one at 2 places, approximately around I say leave 0.2 around 0.8 mm of this width if you provide, you have a extremely functional but yet rigid object, all done by 3D printing. While the previous object, this one requires obviously laser cutting and a little bit of trimming here. Now, do you see those slots which I was talking about? These are the 2 slots that have been provided, so that the connector can be pushed inside. Now, I will go a little faster. Do we stop here, or can we, what do you call, improve our printing capabilities? This looks a little like the IP66 external enclosures that I know people have been what do you call, making use of. So, I see here all the elements which we have put there have been put inside, except that we have a connector here, we have a power supply here, and the whole thing neatly sits into a box. So, it is very much possible for you to make something which is a little like this. Now, how do you take the connections inside, what do you do and all that, that is separate thing. Right now, I am only concentrating on this particular what do you call, way of using this. Now, if you turn it on the other side, you will notice that you have 1, 2, 3, 4 openings, and most likely this obviously is the top cover from this end. These what do you call, pen head screws go inside, and on the other side there are probably external threaded fasteners. And if you see this, you see this fastener has a unthreaded length. It has certain advantages for that. For one of the first thing is, after you push it inside from other way, it sits very comfortably. After this, it goes in, and when you unscrew things here, it will come out easily. Now, these are available in the market without any problem. I am not able to make out whether this is actually something which has been printed, or they have purchased it. Most likely it is purchased it from the market, okay, plain off the shelf. Critical thing what you need to do is, what you need to observe is, you see there is a small projection here all around. Can you see? Small projection here, and correspondingly we have a groove here. This detailing is very easy to create in our what do you call, this solid modeling. All you need to create is, you create an object using probably a polyline command, and you extrude it all around. After doing it, if you attach it here, it becomes part of this. If you remove the material from the other side, you get the negative mold in it, and this red colored thing could be a standard what do you call, elastomer gasketing material, or even you can use your window, the caulking what do you call, you have this RTV compound, nicely introduce the RTV compound, scrape it off, then you place it over this. Maybe you can add a little bit of Vaseline or something, and then you have a practically watertight fit. So, I will go forward and see if I have the, oh, it is hiding somewhere inside. I will get back again, you will probably, you will see it in the next one. Now, see what they have done. I am very thrilled when I see such things. They have made a 3D printed box, and inside you find all the active elements, and it is a wishboard, and a beautiful wishboard has been made such that you can carry it portable. You can do all your thing, that is, take a connection from where the last row of them probably have the power supply or anything, connect it here, and you can have a nicely running system. And you see, one big advantage of this is, compared to the other laser cutting, there are nice tapers given here, which is not possible in laser cutting. In laser cutting, in one setting, normally the openings will be straight. This is a fully printed box, probably printed at home. Can you see here, small extra projection has been given, and if you see very carefully, there is a groove all around. See, can you see this groove? And the same fastener which I showed you there earlier is now here, so that the printed circuit board is held. So, I have one fastener here, and we have a power supply, and there is a provision for connectors here, and then all the thing is written saying where the power should come, where the other thing should come, and all that which are there. Once you close it, say how cute it is. This is starting point. Close it. Good. I have a hinge, I have everything. Once I closed it, you see here I have a provision for the slightly modified version of the USB, not the standard USB which are using it. I think there is a type A, B and C and so on like that. And when we come to that, I will show you. The other side, the fasteners that are used have been shown some reason, correct, yeah. So, the starting point now seems to be very easy to create those things, and even the hinge can be created by us, and in principle it looks cute, neat, and I am acknowledging that it is taken from their website. So, I cannot read it. It says I think Cree Lab. Next picture shows you once again a little similar to that, except have you noticed something here? They have to make some elaborate arrangements to keep this spacer. The very fact that I can see something here, probably there is a vertical limb here. This vertical limb and this whole clamping down is able to keep it together. You can see here there is a thickness here, there is a thickness here, there is a small space built into this. Now, you will notice that whenever we are trying to use these flat panels which are cut and all that, there is little bit of extra equivalent about one thickness comes on all sides. There is no simple way of getting over it. If you try to get over it, it will be like that little green box which I have shown you. While it is compact, it is not as elegant as possible. So, I will show you via media how we can. Now, if you go search on the internet, absolutely lot of these open source files are available. This is nothing but the same thing which is covered with a backing sheet, and usually this can be even what you call printed, or I am sorry, not printed, it can be cut using a laser with this brown paper cover which is stuck inside. It gives a neat cut, and finally you can assemble this nice box which I have shown you earlier. You have seen this box. Now you will notice that you see here this goes and sits there, this lug sits there, this lug sits there, and everywhere a minimum of one thickness is required here. Then the whole thing sits properly. And now you see here on one side we have place for the connectors, and another side back is the, this thing, and it comes with on beautiful things, all these parts come there. So, in fact there are people who ship it to you directly. If you are let us say you are actually an electronic enthusiast, and you would probably get to start off and you are not into designing these things, it comes directly shipped for you. You just need to insert it, and then this is what I was telling you. See these beautiful hexagonal pieces, these are all the various types of spacers which hold in place. Why I am saying this? Now, if you are to make your own clone board, the next subsequent things will talk to you. If you are making a clone of that, not the Arduino standard thing, but if you use all this processor and all, make your own compact thing, then you can probably make your own this thing. You need or need not depend on this. Seen this, no? Everything is there. And you see here one small thing is the small supports are required here, otherwise this thing is likely to collapse inside. And unlike earlier thing, especially if you are doing an etching technique like printed circuit boards, in which you do what is called routing, you can in laser printing, in laser cutting, you can make the parts separate, they will just stay in place, you can remove it afterward. Same it is with a 3D printing. These parts can be printed actually, the same file can be used. When the file comes, sometimes it will already come in a what you call simple drawing PDF or DXF file. Using the DXF file, it is possible for you to recreate the objects. Got it, no? When these are supplied, it comes in some format. Sometimes it will be in the PDF, sometimes it will be in AutoCAD DWG or Autodesk DWG format. So many other things are available, including STL layers, including what you call IGS or DXF. The advantage of IGS and DXF is most packages accept DXF in. If you get the dx of n, this outline and all comes. Now it is for you to create the actual object. This I think I showed you already how these fastenings and all come. Now you see things are getting interesting again one more time. Can you see? This is exactly what I was trying to show you by my hand yesterday. This is the small hexagonal spacer which sits inside. It is assembled by push fitting. So you can see one of the spacers here, and then you can see the spacers. These are all just simple spacers. This one has a small hexagonal relief. You either print it or do it by this and then push it. Afterwards we have a very nice insert which is conveniently sitting inside. If you see here, you can have a beautiful insert. It has a small neck like thing, and for safety's sake you can put super glue, or if you are working in a chemical lab where you have access to chloroform, most of these especially ABS and acrylic and all these things melt easily in chloroform. So if you are not what I call familiar, of course you should not attempt it. Otherwise you can always put a drop of solvent which dissolve this. In absence of that, you can always put super glue, and the moment you put it, everything is there. I have 5 things probably which hold everything together. And you have seen one more very interesting thing. This is not, I am not clear in this now whether it is a transparent acrylic or one side sheet is removed and the back there is a backing sheet. If you have a backing sheet, most likely you can keep it until all your work is over, then peel it, and the bottommost one you can always keep it in place. That could be the bottom one and this could be the top one, and you can peel it. And it is possible for you that if you provide small things like any indicators, LEDs and all, they will be visible to you. If you want it to be more visible at the back, you make a small, you peel off that thing at the back. So you have something which actually looks like a working module. Now you see other things which we can also do, and can you see this? This is some other thing, I am not sure what the object here is, and that little bit of overhang that has been given here has been used conveniently as also feet for this. So that if you are to keep it in the normal condition like this, the bottom part does not get scratched. So if you have the front and back parts assembled like this with a small projection here and all that, and you see what has been done here with this on the top cover. This is the interesting part. A hinge has been created. So even if you are to build these things in using our 3D printing techniques, you can build these independently and this corner can be used. That is, you take this piece, assemble these two together, the hinge part is ready, then after that try to assemble this, and then once you put everything in place, you have a hingeable top cover, and then you see this small thing, by that you can easily lift it on both sides. It gives you a double advantage of locking things in place, and this itself is actually a rigid structure. Why is this required? Because you may have to take a cable inside and then plug it in onto the printed circuit board. So it is stating the obvious. Now you see what somebody else has done here. He calls it a clone. It is not actually the standard thing. I do not know. Right now let me not talk about these things. Obviously these have a purpose. Whatever connections and all are available have been brought out. Only thing you will notice here which is very, very useful is there are a lot of openings here, and you have a look at this finish. If you see, it looks a little bit coarse. This shows it is a honest representation of what actually they have achieved, which I am extremely happy that somebody has posted it. You see here, this is how some of the less expensive home things are likely to look, and the resolution also has been set. But interesting things what you need to observe is, if you see on the other side of whatever it is, you have seen that there is a hexagon and a threaded insert has been push fitted into that. In these cases, because the pulling force or anything is from this side, you do not need to worry too much about it, except any glue you can use in case you have a two component what do you call polyester resin. You can have this glue which is used here. Functionally this is very good, and they have tried to take the best advantage of little bit of detailing which he has learnt. Obviously he is a person who is very, I am very extremely happy to see that somebody has made this. It looks not great, but for me it looks authentic.